How's it going, everybody? This is Beat the Bush. This is the WattCycle Golf Kart battery, 51.2 volts, 16 cells, 105 amp hours. This is one of the more powerful batteries that I've tested. It can do 250 amps continuous, which means it's 12.8 kilowatts. You can drain the entire thing at that rate and it'll take about 25 minutes. I was surprised to look at their manual here, and they even have a 70 volt, 105 amp hours for a maximum power output of 17.6 kilowatts. Today I'm gonna be testing this in a hybrid inverter environment, not in a golf cart, so we can still test the capacity and the maximum power output, not 12.8 kilowatts, but I can do the maximum at my hybrid inverter, which is 5 kilowatts. Probably not a good idea to buy a golf cart battery to integrate into your home backup system. Why? Because it comes with these cable things. This would add extra cost, and you cannot stack these very nicely like in rack mount batteries. So unless you're getting a really good deal somewhere, you should go with a rack mount battery instead if you're trying to build a home backup system. This is for a golf cart. If you're gonna use a 250 amp continuous, your golf cart probably has some pretty beefy cable, and I've been doing an installation of a hybrid inverter that would use 250 amps, and I was using 4/0 cables in it, 4/0, so it's pretty beefy, like this big, and they're pretty expensive cables as well. What's included here? This really heavy battery, user manual, 6 longer terminal screws with 2 shorter ones, and a cable that allows you to monitor the capacity of the battery, the voltage of the battery, and also the temperature inside the battery. This is actually one of the nicer cables that comes with a golf cart battery. It's encased in this wire harness. However, it does not come with mounting screws. The screws that you need to, mount the entire battery on these little holes on the side here. For this one, you're just gonna have to supply your own and bolt them down into the golf cart yourself. First, let's do a capacity test. I drained it with various loads. I'm not wasting electricity here, so I'm charging other power banks, so the load is going to vary a little bit. Discharging from completely full to completely empty, all the way down to about 40 volts, which you really shouldn't do that too often, but I'm doing this more for a capacity test. I got a total capacity of 108 amp hours. This is 3 more than the rated 105 amp hours, so capacity is verified. I have a sense resistor over here. It's reading 53.1 volts. The included gauge also says the same thing. The capacity on this gauge is not too accurate. It's just based on voltage. However, this gauge is a little bit better. It says 60%. It also reads the internal temperature, 73 degrees Fahrenheit, and the charge or discharge amperage. When it has a little battery icon over here, it's discharging, and when it's charging, it'll have a little blinker thing that goes upwards. And let's start discharging it. I'm able to do 4.5 kilowatt out of this thing. That's quite a lot, 88.5 amps, and we'll see how it goes after half an hour. This is getting a little bit too hot, 190 degrees Fahrenheit. I think I need to stop this test simply because my breaker can't handle it. I've discharged about 1/3 of the battery in about 27 minutes or so. Ignore the cables, they're kind of warm. They're only 2 gauge. Nothing out of the ordinary. The battery itself is not that warm, which is really good. This is Bluetooth connected, so I can pull up the app. On the bottom left, there's the temperature logo. If I select that, we see the environment temperature is 86 degrees Fahrenheit inside. That's just somewhere in the open space in there. MOS temperature, 89.6. The cell temperature of T1 through T4 is 84.2, 82.4, 84.2, 82.4. A small difference between T1 and T2. If we select the voltage at the bottom, 52.8 volts, it will show you the voltage of all 16 cells. There's a difference of 0.003 volts. In the app, you can enable or disable charging. So I'm gonna disable charging right now. And all of a sudden, it's not charging the battery anymore. It's only discharging. So I'm gonna turn it back on, and all of a sudden 20 amps can be charged in it. And in the center, it also reads how long it'll take to recharge this thing at the 20 amps. So it's estimating about 4.2 hours, but it's fluctuating a little bit because my inverter somehow, it's not charging it very smoothly. Sometimes it's 15 amps, sometimes it's 11, sometimes 28, but on average, it's supposed to average around 25 amps. You have 2 power switch buttons. When it's flush, it's in the off position. So if you installed it in a golf cart, it should be like this. And at the controls at the seat, you have this power button here. You can push it, and the entire thing will turn on, and if you push it, it turns off. If you turn this switch on, it will turn on, of course. And if you use this button, it doesn't really work. You can't turn it on 2 times. If I turn it off, it's not gonna turn off. So if you want this button to work, leave this off and use this button instead. This display is pretty sharp. Reads the voltage at the top, lithium 44%. When it has this battery icon, is draining itself. 84 degrees Fahrenheit is the internal cell battery temperature. And this is the amount of current that it's draining or charging. The back allows you to install it to the front panel. For this switch, you have to drill a hole and mount it onto the front panel. A really cool thing is that this is connectorized. If this switch ever breaks, you can just push this, take the switch out, buy a new one, and replace it as needed. The connector here is pretty beefy. It allows you to lock it by pushing that tab in, and now you can't open it even if you push that tab. You have to pull this out and then push on that tab and pull the entire connector out. This looks to be a pretty high quality connector, 16 contacts in there. And it's always nice to see all these cables that are labeled in there. These battery terminals are covered. Pull it out like that. They're not rubber sealed, so it's not that waterproof. However, if you get water on top of this, it will drip off onto the side rather inside the battery. You can see there's a lip right here and it goes all the way around like this. Positive terminal, negative terminal, switch, communication port, and also a vent in case pressure builds up inside. The name Ultra is very suitable for this battery because most of the time I only see them go up to 100 amps. 250 amps is just a monster. Because it's only 105 amp hours, you can discharge the entire thing in 25 minutes. That's around 2.5 C. Very, very high discharge rate. You have these very beefy handles. However, they're not very good for carrying it for very long. Just enough so that you can lift it and put it in its place. I like looking inside golf cart batteries because they're easily disassemblable. This cover is metal, and they line the top with a piece of plastic so that in case this gets crushed, the top gets dented in, it won't short out those batteries. Sealed all the way around to prevent water from leaking in. Look at these giant bus bars. I really wonder how many gauge this is equivalent to a cable. This is the positive terminal. Just from the coloring on the side, it looks like it has pretty high copper content. But the top surface is silver, so it's probably tin plated. I've seen a lot of rack mount batteries, couple of golf cart batteries, but this one is the only one that kind of impressed me. Let me point out why. The cells that they pick is perfectly fit for this case here. So they probably designed this case just for these size cells, which runs all the way down to the bottom. They're about this wide, and you got 8 of them that goes this way, and then 8 of them that goes back. Let's run through where the current goes. The positive terminal goes in over here, goes through this cell. The cell has 2 terminals, 1, 2, right? The second one is flipped over, so 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. It goes from here to here, one short bar, and then it uses the cell themselves to route the currents. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And over here it uses 3 cables, but it only has 2 nuts, so one of them is doubled up, and it goes down to the bottom to the BMS. The BMS comes back up through some FETs and it connects to this orange bar. Many times when I see these batteries, they use a length of cable that might go from one side of the battery all the way to the other, and this is kind of inefficient because you don't really need a long cable as long as you route the batteries properly. It's a very efficient design. They spot welded all the batteries together, so it senses every single cell. So you're gonna have about 17 sense lines, B0 to B16. Wires routed very neatly, all zip tied. There is a foam layer between the battery and these plates here. Why do you need that? Probably because when you run the battery very hot, sometimes these tabs gets really hot, and if you touch the battery, it's gonna melt the plastic casing on the battery, and you don't want it to do that. So it's a little offset from there, so that's good. There's little holes over here for the vent holes of the battery, and all the relevant bolts that needs to be tight and not come loose are glued down with this red adhesive. In terms of temperature sensing, it has T1, T2, T3, T4. So these are all on the terminal tabs of the battery. It's probably gonna read hotter than if the temperature sensors on the side of the battery. Different ways to do things, I guess. And it also has T5, T6 on the input, output, plus and minus terminals. Many times these terminals, if you don't torque them enough, they're gonna get really hot. That's just user error, and that's gonna sense that. So if you do that, it's gonna prevent you from kind of overheating these terminals, which is really good thing. In the app, it only says T1 through 4, maybe T5 and 6 might be buried in there somewhere, because the other two temperature sensors, one is for the MOSFETs that's in the BMS, and one is for the ambient temperature, which I don't really see anywhere. It's probably on the circuit board down there. Take a look at this battery sense wire. It's riveted in and it's spot welded, so there's a bit of redundancy here. This is the first time I've seen them do it this carefully. Usually I just see it screwed into this plate. Take a look at this temperature sensor. It's riveted in, spot welded, and the sensor itself is clamped onto this connector. If you look right next to it, this temperature sensor looks to be a little bit bigger. I can't tell if it's a different type of sensor or whatnot, but these are the ones that's on the input-output terminals. I want to draw your attention to the bracket that's holding the battery. This is kind of like a metal alloy. It's not a plastic bracket here. Quite hard. Each of these 8-cell subpacks is like one single unit. There's a metal end piece here and here, tied together with two metal straps, one on the top and one further down. And then these are all screwed to the bottom with 4 screws, 1, 2, 3, 4. You can't really tell from looking at the top here, but the center 6 of the 8 cells is kind of mounted slightly upwards. Just staring down this hole, it looks to be off by about 3 millimeters. Since these are spot welded together, and it's kind of being squeezed, probably won't move anyway. Between each battery, they also add a spacer. That's important to absorb any kind of battery expansion. And I would say that's pretty typical in battery assemblies. The negative terminal is connected here, connects to a bus bar onto 3 bolts on the PCB. And down there, 3 cables connects to the 3 bolts and comes back up. Here we see 2 cables connected to this one and 1 cable connected to here. Not in the manual is the peak current. This can handle 250 amps continuous. This is not a peak rating. It's continuous, meaning you can drain the entire thing at 250 amps. The peak rating is even higher at 600 amps for less than 32 seconds and 1000 amps for less than 2 seconds. 600 amps is equivalent to about 30.7 kilowatts. 1000 is around 51.2 kilowatts. With that much power, you can drive 4-person golf carts. It's important to not overbuy your battery because your golf cart might not be able to handle the 250 amps, 600, 1000 amps. Check with your go-kart's motor specifications and see what your current battery can do and buy the proper battery for your go-kart, because sometimes you might have a go-kart that doesn't need as much current, you can't even use it, and so you might be overbuying it and the BMS might be too strong. You might only be using 200 amps of the 250 amp BMS. Overall, this is a superb battery, even though it doesn't contain all the bolts to mount it in your golf cart. And little nitpicky things I had along the way during the teardown, I would recommend this. It has superb build quality. Thanks for watching this video. If you guys are interested in getting this WattCycle golf cart battery, check out my affiliate link down in the video description below. Thanks for watching this video. Until next time.